Hello everyone, welcome to my video. Today's subject is analysis and design of algorithm and the topic is on heap sort algorithm. First, we'll learn what is the meaning of heap. A heap is a binary tree with keys at its nodes, one key per node, such that it is essentially complete. That is, all its levels are fully except possibly the last level where only some right most keys may be missing. The key at each node is greater than or equal to all keys in its children. Here are diagrams which represents a heap. Here heap is balanced at one end, it is a non-balanced which is not a heap. The important properties of a heap. Given n nodes, there exists a unique binary tree structure with n nodes that is essentially complete with h equal to log to the base 2 into n. The root contains the largest key. Every subtree rooted at every node of a heap is also a heap. A heap can also be represented as an array and usually we can see in the next page it is example and then explain the array representation. It also works. Heap construction has two types, bottom up heap and top down heap. First, bottom up heap, which initialize structure E array with keys in order given, starting with the last rightmost parental, which is interior node. Fix the heap rooted at it. If it doesn't satisfy the heap condition, keep exchanging it with its largest child until the heap condition holds. Now repeat the steps for the preceding parental node. Bottom up is a heap construction where it adds nodes to heap from bottom to top, pushing elements down as needed. Another is top down heap. It is basic operation in building heap in top down order. Insert the new element at last position in heap. Compare new element with its parent and if it violates heap condition, exchange them. Continue comparing the new element with nodes of the tree until the heap condition is satisfied. Now repeat this process until the heap properly is property is restored or the element reaches the root. This is the algorithm of heap bottom up. First, the command lines we should construct a heap from the elements of a given array by taking input h into 1 to n of orderable items and we get the output as h from 1 to n. Now the for I n comma 2 belongs to I down to 1 do this line starts from the last non-leaf node which is at index and goes up to the root. Leaf nodes from Ln 2 to 1 plus 2n are already heaps of size 1. Next line, the ki belongs to k, v, h of k is v. This initializes k as the current node index, where v stores the value at index k for later use. False heap. Heap is a flag indicating whether the subtree rooted at k satisfies the heap condition. While not heap and 2 into k is less than n do, this line will help in continuing while the node has at least one child, which is left child which exists, and the subtree isn't a heap yet. Next line 2 into k to j, where j is the left child of k. Here, if condition, we suggest if the right child exists in j plus 1 is less than n and it's larger than left child, then j is set to the right child. Next, another if condition where heap is given as true. If the value v is greater than or equal to its largest child, the heap condition holds and the loop can stop. Or else, otherwise, move the larger child to replace v and continue down the tree, shifting v down. Finally, we'll place v in its correct position to maintain the heap property. This algorithm shifts down each non-leaf node from bottom to top, ensuring the max heap property is preserved. This is more efficient 0 of n O of n than inserting elements one by one, which takes O of n log n. Here are the two examples of bottom-up heap and top-down heap. In first bottom-up heap, first we'll construct the tree by given elements. Here the given elements are 1, 8, 6, 5, 3, 7, 4. First we'll construct the tree and we'll check the parental dominance. Here the parent root node number is lesser than the child node, so we will shift 6 with 7, then we'll get this tree. Now we'll check the parental dominance. Here the parental dominance satisfies. Now next we'll come to the root node where it does not hold the parental dominance, so we'll shift the number 1 with 8. After shifting uh, by subnode, there will be no parental dominance, so we'll shift with 1 and 5. It is bottom up heap. Next, top down heap. Here we'll construct the tree step by step by taking every element. First 1, then we'll insert 8 at right end. We will exchange because it does not hold parental dominance. 8 comes up and 1 comes down. Then we'll insert 6 after 5. Here no parental dominance, shift or replace 1 with 5. Next we'll insert 3 after 7. No parental dominance, shift 6 with 7. Next insert 4. This holds good. No, it shows the parental dominance. Conclusion of the topic is heap sort is an efficient comparison based sorting algorithm that uses a binary heap data structure. It ensures a consistent time complexity of O(n) log n for all cases, making it suitable for large datasets. The algorithm first builds a heap and then repeatedly extracts the maximum or minimum element to produce a sorted array. Heap sort is in place but not stable. It is widely used when memory usage is critical and predictable performance is required. Thank you for watching this video. Please like it.